Water resources will fluctuate increasingly and become more and more difficult to predict in snow-dominated regions across the Northern Hemisphere by later this century, according to a comprehensive new climate change study led by the National Center for Atmospheric Research, NCAR. Water managers will be at the whim of individual precipitation events instead of having 4 to 6 months lead time to anticipate snowmelt and runoff, said NCAR scientist Will Weider, the lead author. Water management systems in snow-dominated regions are based on the predictability of snowpack and runoff, and much of that predictability could go away with climate change. Observations show that snowpack is already melting earlier, and even declining in many regions. This decline will become so pronounced toward the end of the century that the amount of water contained in snowpack at the end of an average winter in parts of the U.S. Rocky Mountains could plummet by nearly 80%, the scientists found. The changes in runoff and streamflow are likely to have cascading impacts on ecosystems that depend on reliable water from snow, the study warns. Although the changes won't be uniform across regions, more snow-free days and longer growing seasons will put stress on water resources, drying out soils in many areas and heightening fire risk. Although past research looked at the impacts of climate change on water availability, the new study focuses on the increasing variability of water resources. The study is being published the week of July 18 in the Proceedings of the National Academy of Sciences. It was funded by the U.S. National Science Foundation, which is NCAR's sponsor. A race with predictability. Many regions of Earth rely on the accumulation of snow during the winter and subsequent melting in the spring and summer for regulating runoff and streamflow. For years, however, scientists have warned that the snowpack will become thinner and melt earlier as more precipitation during the colder months falls as rain instead of snow, and as melting occurs at times during the winter instead of the spring runoff season. To determine how reduced snowpack will affect the variability of water resources, Weider and his co-authors turned to a powerful NCAR-based climate model, the Community Earth System Model, version 2. They drew on a recently created database of simulations, known as the CESM2 Large Ensemble, to compare a past period, 1940 to 1969, with a future period, 2070 to 2099. The simulations were run on the Aleph supercomputer at the Institute for Basic Science Supercomputer in Busan, South Korea. There will be an average of about 45 more snow-free days yearly in the Northern Hemisphere, assuming high greenhouse gas emissions. The largest increases will occur in mid-latitudes that are relatively warm and high-latitude maritime regions that are influenced by changes in sea ice. Many regions that rely the most on predictable relationships between snowpack and runoff will experience the largest loss in predictability because of a sharp decline in reliable pulses of spring runoff. These regions include the Rocky Mountains, Canadian Arctic, Eastern North America, and Eastern Europe. The authors warn that this will substantially complicate the management of freshwater resources, both for society and ecosystems. We are in a race with predictability when it comes to streamflow because we're trying to improve our forecasts through better data, models, and physical understanding. But these efforts are being cancelled by the rapid disappearance of our best predictor. Snow, said Flavio Lenner, a professor of E. It might be a race we'll lose, but we're trying to win it, and that is why we need to study these topics. Although the reduced runoff will result in drier summertime soil conditions in much of the Northern Hemisphere, the simulations showed that certain regions, including East Asia, the Himalaya, As utilities and civil works agencies plan new reservoirs and other infrastructure to adapt to a changing climate, we must address basic research questions about the changing characteristics of winter snowpack and resulting streamflow that we have long relied upon. William R. Weider, Daniel Ken. Proceedings of the National Academy of Sciences, 2022. 119, 30, doi, 10. 1073, PNAS. 22023931119 National Center for Atmospheric Research, University Corporation for Atmospheric Research. Water resources to become less predictable with climate change. Declining snowpack will cause more variability in runoff, streamflow. Science Daily. Water resources to become less predictable with climate change. Declining snowpack will cause more variability in runoff, streamflow. Science Daily. Retrieved July 18, 2022 from ift.tt/dq203qw National Center for Atmospheric Research, University Corporation for Atmospheric Research. Water resources to become less predictable with climate change. Declining snowpack will cause more variability in runoff, streamflow. Science Daily. https://ift.tt/dq203qw. Accessed July 18, 2022. Thanks for watching. Please subscribe my channel for more videos.